Let me share with you some pictures that illustrate iron toxicity. And iron toxicity often shows itself as leaf burn. And so in this picture here, this is a picture of rice that is suffering from iron toxicity. And simply because the soil had been flooded, it doesn't look like it's flooded now, but it was flooded at one point in time. And iron 3 was reduced or changed or altered to iron 2. And iron 2 can be up to likely 1,000,000 times more available than iron 3. And so this plant or these plants have suffered. They just don't look right. And you can see some leaf tip burn on these plants. Important to note that I can't teach you everything in this class. And there are interactions between nutrients. In this case, there's actually an interaction between iron and potassium. And oftentimes in rice, when we see an iron toxicity, it states here that potassium may be deficient in the soil. And how do you know that there's an iron issue? Well, look at the soil surface. And it even states this in the figure caption, a red-brown skim on the water. Okay, actually there is water there. A red-brown skim on the water indicates excess iron. There is excess iron that's coming out of the soil and it's actually showing itself on the water, which is interesting. But the bottom line here is that you see leaf burn. So let me share with you a couple other pictures. So if you were to look at the leaves up close, you would see leaf burn. And although it manifests itself along the margins of the leaf, when you look at all these leaves, it just looks different. And you may suspect that this is a potassium deficiency. And you know what? It may actually be a potassium deficiency induced by excess iron. And so the issue is excess iron. You also see that in other plant species. Here's marigold. You see leaf burn. It looks like it's along the margins of the leaves in this picture. And it could be a potassium deficiency that's simply manifesting itself and being masked by an iron toxicity. And so what happens? And we've talked about this several times already throughout this course. When a plant perceives a toxicity, the root system suffers. And so here's a picture of rice growing in control. So likely very low, if any, well, there must be some iron concentrations, and rice growing in high concentrations of iron +2. And there were different plant species that were studied in this study. And you can see the effects from right to left. Boy, what an effect, right? Correct. And this is what this looks like in the below ground growth. So the plants that do well have a pretty extensive, I guess for young plants, root system, and plants that are poor in terms of above ground growth, the roots simply suffer. And this is because of iron toxicity killing the apical meristem and leading to shortened, stunted roots that show themselves visually to us as a shortened, stunted, burned above ground growth. And the last two pictures I want to share with you come from an area that have been affected by historic mining operations. And the soil underneath this grass, this is not rice, this is just a cool season grass grown at high elevation. This area under the plants has a pH of 3.8. And so these plants have found a way to survive, but they look pretty brutal. And you can see the leaf burn in this picture on the left. And if you zoom in, you can actually see it a lot better, especially with this blade here and some of these other blades that are simply just completely dead. This looks like a potassium. It could look like a potassium deficiency, but the leaf is really scorched and it's burned and it's along the margins. And that tells you that it's likely an iron toxicity. To prove it for certain, you could take a soil sample and plant tissue samples and analyze them for a number of different elements, and it would likely tell you that it is a toxicity. And the pH would likely tell you that there is something seriously wrong with this soil because the pH is 3.8.